My wife and I ran a small organic farm for a few years. It was physically challenging, but it was also some of the most intellectually challenging work I have ever done. I had to understand and apply, in the moment, a wide range of fields, including biology, ecology, engineering, technology, and marketing. The farm would teach me new lessons every day, new observations of nature to integrate and understand. It was at least as challenging as the technology development work I'd done before in renewable energy, telecommunications, internet, and computers. Like my organic farm, creating sustainable landscapes is knowledge-intensive and multidisciplinary. In this lecture, we'll explore sustainable landscapes. We're used to thinking about getting food from a garden, but there is so much more that sustainable, functional landscapes can do. Sustainable landscapes are those that work within the natural cycles of soil fertility and rainwater, without toxic chemicals. Functional because they are not only beautiful, they also provide for human needs. Here are some of the things our landscapes can provide our households and those of our neighbors if we design them to do so. Herbs for use in teas, tinctures, creams, and salves. Craft materials like basketry and weaving materials, beading materials and soaps. Paints and dyes, glues and adhesives. Water services like infiltrating stormwater and purifying polluted waters. Perfumes and fragrances. Building materials like bamboo, willow, and lumber. A well-designed, functional landscape can also attract or repel wildlife, beautify your home surroundings, and help meld the inside living space with the outside, increasing the amount and quality of space in your home. They can also screen out unwanted views and noise. Geoff Lawton, a well-known Australian permaculture designer, refers to the regenerative power of biological systems when he states, "We can fix all the world's problems in a garden. You can solve them all in a garden. You can solve all your pollution problems and all your supply line needs in a garden." Permaculture is an attempt to design human habitats that have the stability, diversity, and resilience of natural ecosystems. It was developed by Bill Mollison and David Holmgren in Australia and has a strong emphasis on creating landscapes around homes and cities that meet human needs. George Washington Carver was an early pioneer in getting human needs met in a garden. Born into slavery in 1861 and educated at Simpson College and Iowa State University, Carver dedicated his life to improving the life of small farmers by enabling them to meet their needs from products from the farm without having to participate in the cash economy. Carver developed thousands of new uses for plants, including soap and ink from peanuts, a building wall system made from cotton stalks, and 75 products made from pecans. The first thing you want to do is to look at your soil. Soil is a complex mixture of minerals, organic material, water, and life. My microbiologist colleague Elaine Ingham named it the soil food web, and it is the foundation of the web of life. We're used to thinking of soil as a lifeless substrate for growing plants. We treat soil like dirt. Well, dirt is inert, but healthy soil is teeming with life. A single teaspoon of soil holds up to 1 billion bacteria, several yards of fungal filaments, several thousand protozoa, and scores of nematodes. These microorganisms are supplemented by larger creatures like worms and millipedes. Charles Darwin wrote this about worms. "It will be difficult to deny the probability that every particle of earth forming the bed from which old pasture land springs has passed through the intestines of worms." When organic matter and soil pass through earthworms' guts, nutrients are put in a form that is readily absorbed by plant roots. Worm poop, or castings, are a mix of soil, beneficial microorganisms, and organic substances beneficial to plants. They're a great plant fertilizer and soil enhancer. Worms create tunnels that allow for water, air, and root movement in the soil. Worms incorporate organic matter deep into the soil and move buried nutrients closer to the surface. Darwin estimated that earthworms turn over the top 6 inches of soil every 20 years. An acre of land can contain up to 1 million earthworms. A ton of cows in a field depends on several tons of earthworms that are below the surface. Want to encourage earthworms in your soil? Well, provide plenty of organic matter for them to eat, preferably applied as surface mulch. Worms love newspapers, so recycle your newspapers in your garden as mulch or shred it for the compost pile. And worms need undisturbed soil. You can gently aerate soil with a broad fork, but aggressive tilling is not good for luring worms. Research on the soil food web in the last 20 years has demonstrated that plants get what they need to be healthy through their relationships with life in the soil. Plants take sunlight and create complex chemicals like carbohydrates. Soil microorganisms cooperate with plants by converting soil nutrients into forms plants need in exchange for complex carbohydrates the microbes need. Ever wonder why young trees can grow green and healthy in the shade below mature trees? Well, young trees have been found to get up to 60% of the photosynthetic products they need from the larger trees through the mycorrhizal fungi networks surrounding their roots. Some mycorrhizal fungi even penetrate the cell walls of the roots as part of their symbiotic relationship. The largest single living organism found to date is a fungi covering 2,384 acres of forest in Oregon's Blue Mountains. It's estimated to be at least 2,400 years old, but may be as old as 8,650 years. Mycologist Paul Stamets has some basis to his claim that fungi rule the world. The sustainable approach to soil fertility is to take care of the life in the soil, then the life in the soil takes care of the plants. What can you do if your soil is deficient in soil life? The simple answer is compost and organic matter. Learning to make good aerobic compost, teeming with beneficial microorganisms, is a key skill in sustainable gardening. Now, aerobic means in the presence of air, and anaerobic means that air has been excluded from the process. The majority of beneficial microorganisms are aerobic. Let's take a look at what goes into making good compost.
Hi, my name is Zach Wright. I'm the director here at the Living Soil Compost Lab in Fairfield, Iowa. And today I'm going to show you how to make a bacterial dominant compost pile. Now, why I'm choosing a bacterial compost pile is because we want to grow vegetables. And vegetables, they need something more bacterial versus fungal. My ingredients include comfrey and weeds chopped from around the area. This is my green material. This is my brown material, mulch. This was harvested from the local municipal mulch waste pile, so free and free. And my third and crucial ingredient, beer mash, which is our high nitrogen component. So basically, to make this pile, we have a recipe. And because we're going for this particular recipe, we're going to look at this in proportions. 20% high nitrogen, 30% woody mulch, and 50% our green material. This is going to achieve ideal conditions for a bacterial compost pile. So basically, I'm going to take 5 scoops of the green material, then 3 scoops of the woody material, and then 2 scoops of beer mash, which I'm going to sprinkle onto the pile. Once I have those all mixed together, I'm going to hydrate them. Now, something to be careful when hydrating and using tap water is tap water can be conditioned with things called chlorine and chloramine. Chloramine is a chemical that will essentially kill biology. Because we're after biology, we treat our tap water with humic acid, which is derived from the compost. We're going to continue building the layers of the pile until we reach our desired size or we've run out of materials. And this is called aerobic thermal composting. And we hope to have a finished product under 4 months. So I'm here with a 9-day-old aerobic thermal compost pile. And 9 days ago, we put our green material, our brown material, and our high nitrogen material together in a particular proportion. And 9 days ago, it was about this tall. And so already we've decomposed the organic matter down to, I would say, at least half, if not more than half of its original size in only 9 days. We have created an environment for the microorganisms to decompose as rapidly as possible and convert our organic matter into humus, essentially. In order to meet organic regulations, we have to monitor the temperatures and the moisture as well. So depending on your high nitrogen component, you're going to be turning this. You're going to be actively engaging this pile for the first 15 days. But this is to ensure quality, and this is to ensure safety, because we want to kill any sort of pathogenic organisms that might be in our material. So after our aerobic thermocompost pile has gone through all the necessary conditions that it's needed for decomposition, for rapid decomposition, we take a product like this, we take materials like this, wastes essentially, and convert them into a finished product such as this in as little as 3 months. Teeming with microbiology, aerobic microbiology, which is essential for plant life, and well, it trickles up back to us.
Compost and organic matter are the keys to healthy soil life and good soil tilth. Good tilth means that the soil has structure that encourages plant growth. Aerobic compost teas and extracts can make a small quantity of compost go a long way. Good compost tea can be sprayed on leaves to control diseases. The beneficial organisms colonize the leaf surface and outcompete the disease-causing organisms. Here's Zach again to show us how to brew a small batch of compost tea.
So basically we're going to be making compost tea now. So all we need is a 5-gallon bucket, a pond pump, and then a little apparatus or something to hold our tea bag inside of our brewer that we're aerating. So we fill our 5-gallon bucket with tap water. Now, depending on what your tap water is treated with, be it chlorine, chloramine, it is advisable to treat the tap water with some sort of carbon filter. We at the Living Soil Compost Lab use compost as our carbon filter. We basically run the tap water through the humics that are in our compost, and those humics complex the chemicals that are used to treat our water. Because basically treated water is sterilized water, so it actually works against the biology that we're wanting to promote. So once we've treated our water by running our tap water through our compost carbon filter, then we take 2 to 3 pounds of high quality biological compost and we put it into a tea bag and we submerge it into the water for 24 hours. After 24 hours, we have 5 gallons of high biological compost that we can then apply to the foliage of any plant.
The compost process generates heat as a byproduct. It's possible to make use of this heat for hot water, buildings, or greenhouses. Ben Falk of Whole Systems Design has created a hot spring in the winter in Vermont using water heated with compost.
Good. This is our Vermont-style hot spring, powered by rotting wood chips and horse manure. Before running it into raised beds in the greenhouse, we're testing it in a little hot tub setup here, just to see how much hot water we're making. Here's the greenhouse at the Whole Systems Research Farm. We finished in the fall 2012. It's designed to be passively heated via the sun and earth coupling only via ground temperature, because the ground is a lot warmer than the air for nearly the entire winter here. That'll also help cool it in the summer. And then, since we have a need for constantly growing soil anyways, and there's a lot of wood chips available for free nearby, people are always chipping up trees and dumping them. We take those chips, we pile them up, we compost them, and we also harvest a lot of horse manure that people give away for free. This is about 12 to 14 yards of wood chips and sawdust. The rest is horse manure, about 3 more yards of horse manure. We put 800 feet of 3/4 inch poly tubing in the mound as a heat exchanger. Pump water through all that tubing, it picks up the temperature, it goes from about 45 degrees from the ground, where it comes from, which is our well. When it comes out of the mound, it's about 140 to 145 degrees. Wow, that is hot. Hot water coming out of compost. Just an amazing thing that there's that much biological heat coming out of this mound. And that there's all these compost piles and piles of wood chips rotting, wasting all of this heat. This is precious, amazing heat source. Tapping off of a compost pile. Being outside on a sunny day with 2 feet of snow on the ground, it's 20 degrees. There's plenty of warmth to go around. Multiple functions from single elements. Not a bad way to go, really.
Now that we understand the basics of the soil food web, let's explore some sustainable plant selections. You'll need to select varieties that can withstand the winter temperatures in your location. The USDA has established plant hardiness zones that range from 3, the coldest, to zone 10, the warmest, in the continental United States. Plant hardiness zone ranges are available for most plants from a variety of sources. Be sure you're planting from an up-to-date zone map. There are 2 basic kinds of plants for your landscape: annuals, which need to be planted from seed every year, and perennials, which are planted once and then provide a yield for many years. There is also a kind of hybrid, annuals that self-seed heavily and come back every year like perennials. Now, most vegetables in the grocery store are annuals, and most fruits and nuts are perennials. Sustainable gardening puts a focus on perennials as a way to maximize results you get from the effort you put into gardening. The Land Institute in Lenexa, Kansas is working to develop perennial versions of all the main grain crops, including wheat, sunflower, rice, and corn. Perennial plants have deep roots compared to annuals. Deeper roots mean resistance to drought and the ability to access nutrients deeper in the ground. Deeper roots can take advantage of a wider scope of soil. Now, perennial grains would allow grains to be grown in perennial polycultures, mimicking the prairie. Polycultures are groups of plants that have a synergistic effect when grown together. For example, growing a nitrogen-fixing plant like clover along with wheat minimizes the need for nitrogen fertilizer. Monocultures or monocrops are plantings that feature just one species. Monocrops tend to be more susceptible to disease and insect problems. Most natural ecosystems are diverse polycultures. One of the problems with our commercial approach to agriculture has been its focus on monocrops and monocultures. It's a perfect example of working against natural principles rather than working with them. Sustainable agriculture focuses on polycultures for these reasons. Although most of the perennials that are familiar are berries, vines, fruits, and nuts, there's a surprising number of perennial vegetables. Some are more familiar than others, like asparagus, sorrel, and artichokes. Good King Henry's leaves cook up like spinach, and its shoots can be used like asparagus. With daylilies, the unopened buds can be sautéed with a little butter and salt. The flowers are good in salads, and the tuberous roots can be cooked like the buds or roasted with oil and seasonings. Jerusalem artichoke is a delicious tuber with no relation to the artichoke. Now, many herbs are perennials in most parts of the US, or they're self-seeding annuals, things like chives, garlic chives, thyme, and French tarragon. In addition to their return each year, another advantage to planting perennials is that they get a head start in the spring, extending the season. Trees can require a lot of work. They need to be mulched, fertilized, and protected against insects and disease. What if we could get the needs of the tree met instead by other plants? A group of plants that work together to meet mutual needs is called a guild. A guild typically has a central plant and a group of plants that cooperate to meet the needs of the central plant. Guild plants should include a nitrogen-fixing plant, which takes nitrogen from the air and makes it available to the main plant. Nitrogen-fixing plants include beans, clover, and trees like honey locust. A mulch plant provides mulch to conserve water and smother weeds. Comfrey can be cut back several times a season for use as mulch. Insectary plants attract beneficial insects and repel damaging ones. Members of the Umbelliferae family, like fennel, coriander, dill, Queen Anne's lace, and wild carrot, attract predatory wasps. Grass border plants keep out grasses, which have a negative effect on fruit tree growth. Comfrey and daylilies can be planted in a ring around fruit trees to keep out grasses. And dynamic accumulators mine nutrients deep in the soil, and when you mulch with them, they make the nutrients available at the surface. Comfrey is a dynamic accumulator of calcium, which is an important in a grass border plant. The principle of ecological design at work here is to use biological systems rather than mechanical ones whenever possible, because biological systems can use sunlight to self-organize. There are a wide variety of unusual fruits for the home garden. Many of these fruits have superior flavor and nutrition than commercial varieties, but they have characteristics like not shipping very well that make them difficult to grow commercially. The only way you can enjoy many of these fruits is to grow them yourself. Let's talk about some of these lesser-known fruits. Pawpaw is the northernmost member of the sugar apple family. Pawpaw is a tropical fruit hardy to zone 4 and 5. The tree fruits reliably as far north as Madison, Wisconsin. Pawpaw has a creamy, custardy texture and an exotic tropical fruit flavor. It makes a delicious ice cream. If you try one, peel off the skin and discard it. The skin's really not good to eat. American persimmons are golf ball-sized persimmons that must be ripe before eating, otherwise they are extremely astringent. They're smaller than the persimmons you sometimes see in the grocery store. American persimmons ripen late in the year, October into November in Iowa. Fruits are sometimes improved by a frost. I've eaten them off the tree in late November after 5-degree temperatures. Jujube, or Chinese date, has a date-like fruit that dries on the tree. Supposedly hardy only to zone 6, they do well in town in Fairfield, Iowa, which is a cold zone 5. This is an example of the microclimate effect. You can manipulate areas of your yard so that plants technically outside of your growing area can sometimes survive. I can't make promises, but just as there are ways to situate a home for better use of solar energy, there are strategies for situating plants in your yard. Well, what if you don't have room for fruit trees, live in an apartment or rent? You can grow a surprising variety of fruits in containers, and you can grow fruits that are tender for your climate and bring them inside in the winter. I do this with figs in Iowa. You can also consider supporting the planting of public fruit trees in your community if you want to cultivate fruit but don't have the room for trees. My community created a 2-acre community orchard in a public park. The benefits of this public orchard will be enjoyed by residents for decades. This project was spearheaded by our local city sustainability coordinator, who is also an Iowa State University extension agent.
Hi, my name is Scott Tim, and I'm a field specialist for Iowa State University Extension and Outreach. I'm the sustainability coordinator for the city of Fairfield, and my job is a partnership between the city and Iowa State University, and this is the Fairfield Community Orchard. Essentially, what we had to do is choose a site that was really had a lot of moisture in the soil. So we have this spot that's right next to the creek and it has a marsh behind it, but yet the drainage here is really nicely, so we don't have pooling and ponding of water. We also chose this site because the Fairfield Loop Trail runs right along the edge of the orchard here. So there's a lot of traffic, a lot of people who are coming by who have access to the fruit and the nuts and the things that are being grown in this orchard. We also chose this site because there is a senior citizen center just uphill, and they have a lot of water that's coming off their roof. So what we've done is we are able to harvest the water that's coming from that roof into a large tank, and we have a drip irrigation system. So you can barely see some of the lines that are still here. We trenched and ran drip irrigation tubing, and then they call spaghetti tubing, that runs up to each of these trees. So in years when it's really dry, we can pull water and store it, and then use gravity to bring it down. Or if we want, like I mentioned, there's a creek that runs past here. We can also pump water up from the creek actively into all of these trees. These trees were all bare root trees, and so essentially we had to be very careful getting them into the ground and really care for them. There are a lot of deer in this area, so we also needed to surround each of these trees with posts and wire cages to keep the deer from grazing them too heavily. Every year now we're going to expand those cages so that the trees can get larger and larger. This site has quite a bit of slope to it. And so we've planted trees that need less water, that are much more drought resistant up high, and then trees that can handle a lot of water. Things like mulberry and pawpaw and persimmon, they're all down low where we may get some standing water if there's quite a lot of rain. So we thought not only about the traffic and the slope, but we also really wanted to be careful in the species that we selected to make sure that they would be able to survive specific to where they're planted in this site. We have 150 different fruit and nut trees. Apples, pears, we have chestnuts, persimmons, pawpaws, apricots, mulberries, peaches, plums. There's really an incredible variety of trees in here. And we also really wanted to plant a wide diversity because we're not sure what's going to do really well. And so having a wide variety of trees, whether you're planting an orchard or planting for energy efficiency, it's really important to plant a diversity. Once we cleared out this field and we tilled and planted all the trees, we then wanted to have a nice ground cover. What we have here is a lot of clover. It's a nitrogen fixing clover, and that really helps to encourage the fertility of the soil. In addition, we mulch heavily. So every year, twice a year, we come in and we mulch and sheet mulch around every one of these trees. That really helps keep and lock in the moisture over the winter, but it also is helping to build the richness of the soil.
Another community effort in Fairfield was the Edible Cityscapes project, which allowed residents to buy fruit trees at a discount. Over 3 years, 4,000 fruit trees were placed in backyards and along the street in my small community of 10,000 people. If you have a yard full of ornamental fruit trees, you should know that ornamental fruits can be grafted so that they yield full-size fruits. Here's the story of some guerrilla grafting that happened in Fairfield a few years ago. My community has a monthly art walk that draws thousands of people to the area near the Art Center. 3 students from a public fruit group, Avi, Dora, and Brian, dressed up to vaguely look like park rangers with khaki pants and a Smokey the Bear hat. They offered a grafting workshop that looked like it had been planned as part of the art walk. It hadn't. By the end of the evening, they had grafted a dozen or so scions of full-size pears onto the ornamental pear trees. Here's a short video of Brian demonstrating his excellent tree grafting technique. You will need a sharp knife and some grafting tape. You can buy special grafting knives, but the utility knife that Brian is using here works just fine. A diagonal wedge-shaped cut is made on the scion and on the tree branch. The branch on the tree and the piece that will be grafted, called the scion, need to be the same diameter. The cambium layer of the tree and the scion need to line up. The cambium layer is just under the bark. For successful grafting, the cambium layer of the tree and scion must grow together. A slit is made in the face of the wedge on both the scion and the branch. The 2 slits are slid together and interlocked, making a graft that has good physical strength as well as a lot of contact area. The graft is then wrapped with grafting tape. Grafting tape holds the graft in place and prevents it from drying out until the cambium layers have grown together. Now this type of graft is called a whip and tongue graft. Now here's what the graft looks like after a couple of years. The branch and the scion have grown together, and you now have one tree with 2 different varieties of fruit. maybe one that bears early and one that bears late. In this case, we have both ornamental and Asian pears on the same tree. Trees that are going to be grafted need to be closely related, so apples will graft onto apples, but not onto pears. While the details of grafting can be complex, the basic skills are pretty easy to pick up. Another way to connect with your food is to learn about the wild edible plants and mushrooms that grow where you live. Of course, you need to be careful with mushrooms, as some deadly species resemble edible ones. My wife is from France, and she liked to forage for mushrooms in the forest near where she grew up, about an hour outside of Paris. France has implemented a novel solution to the problem of identifying mushrooms. Just take them to a pharmacy. Pharmacists in France are trained to recognize mushrooms. Many people forage for mushrooms in France, and even small towns have a pharmacy. You may find useful plants right in your own neighborhood. While working on this course, I was surprised to find these linden trees in blossom just outside the great course's offices. The flowers of the linden tree make a great relaxing herbal tea. Other common wild edibles include lamb's quarters, dandelion, cattail, and burdock. I suggest you look on the internet to research wild edibles for your area and how to use them. Landscapes can be designed to provide a wide variety of products and services for humans and wildlife. If we make our landscapes beautiful and functional, many of our needs can be met right where we live.